So welcome, this is CAIE May June 2009 Mechanics paper 4. So let us try to solve the paper. There are something around 7 questions. We shall try to solve all the questions. A block B of a mass 5 kgs is attached to one end of an extensible string. A particle of mass M 4 kgs is attached to the other end. So this is 4 kgs. So 4G will be acting downwards and tension will be acting upwards. Similarly, 5G acts downwards and the tension will be acting upwards. The string passes through a smooth pulley. The system is in equilibrium with the string is taut and straight parts vertical. B is at rest on the ground. State the tension in the string. So for tension in the string, we consider that particle P. Up for forward force minus backward force is equal to MA. I do forward force minus backward force is equal to MA. The forward force is 4G minus tension is equal to, it is at rest, so 0. 4 times 10 is equal to tension. So what is the tension in the string? It is 40 newtons. State the tension in the string. Find the force exerted by B on the ground. So at B, what happens is the ground will be also exerting a somewhat force upwards. So this forward force minus backward force is equal to MA. So 5G is the forward force, minus that backward force may be R, minus tension should be equal to 0. So 50 minus R minus tension is just now we got 40 should be equal to 0. From there I get the value of R is 10 newtons. R is the push or force exerted by B by the ground on the upwards direction. So that way we get forward force minus backward force is equal to MA and get the answer. Coming to question number 2, a crate C is pulled at a constant speed up an inclined plane by a constant force of magnitude Fn acting at an angle 15 degrees to the path. The C passes through the point P and Q, which are 100 meters apart. As C travels from P to Q, the work done against the resistance of the motion is 900 joules and the gain in the potential energy is 2100. So total work done will be 2100 plus 900, which is 3000 joules. Now this is the total work done. F is the force with which it is being pulled. So I resolve F1 parallel to the plane, which is F cos 15, and 1 perpendicular to the plane, which is F sin 15. So work done is equal to nothing but what? Force times distance. Force times distance. It has been pulled a distance of 100 meters. So I get it out, 3000 is equal to force is F cos 15 times distance 100. From here, if I do, F is equal to 3000 upon 100 cos 15. So F is equal to nothing but what? 31.1 newtons. Find the value of F. That's it. Question number 2. Coming to question number 3. Find the components of the resultant of the three forces in X direction and Y direction. So 7 newtons I need not resolve because it is already in the X direction. This 10 newtons, so I use a color for that. Maybe 10 newtons, it is a red color, so it goes in this direction. So 1 along X direction and 1 along Y direction. So along X direction it becomes, the angle is 50, so 10 cos 50 and it becomes 10 sin 50. Coming to 15 newtons, let us choose another color for 15 newtons. So 1 parallel and 1 perpendicular. So parallel along X direction will become 15 cos 80 and it will become 15 sin 80. So now along the X directions, 7 is in one direction plus 10 cos 15 is same direction, but 15 cos 80 is in the opposite direction. So I simplify that one. I directly write the answer. It is 10.8 newtons. Now coming along Y direction, we have 10 sin 50 and 11 sin 80 on the top upward direction, nothing in the downward direction. So 10 sin 50 plus 15 sin 80 in the upward direction, which I simplify should be giving you 22.4 newtons. Find the direction of the resultant. So first of all, we have to find it out the theta, tan inverse of y upon x. So it becomes tan inverse of 22.4 upon 10.8, which becomes 64.2 degrees. 64.2 degrees. So it will be somewhere over 64.2 degrees in the anti-clockwise direction. 64.2 degrees in the anti-clockwise direction. So what am I going to write it up? 64.2 degrees anti-clockwise from x-axis. That's question number 3. Coming to question number 4. A block of mass 8 kg is at a rest on an inclined plane of 20 degrees. The block is connected to the vertical wall at the top of a plane by a string. The string is taut and parallel to the line of the greatest slope. Given that the tension in the string is 30 newtons, find the frictional and the normal components of the force exerted by the plane. So the weight is 20. So immediately what am I going to do? The weight is 8 kgs. 8 kgs. So I am going to draw one parallel to the plane, which is 8g sine 20, and one perpendicular to the plane, which is 8g cos 20. So my forward force is only 8g sine 20 is going to be the forward force. Now what will be the backward forces? The backward force is the tension in the string, and there will be some frictional force. So we know that concept. Forward force minus backward force is equal to ma. Backward force is equal to ma. So forward force is 8g sine 20 minus backward force is friction F minus tension is equal to 0 because it is stable. Now he said that given that the tension is 13 newtons, it has been already given that the tension is 13 newtons. So I can plug in that one. 8g sine 20 minus 13 newtons equals to F. So I take quickly the calculator. 8 times 10 times sine 20 minus 13. If I do that one, it should be something around, I'll be getting in 3 significant figures 14.4 newton. This is a frictional force. Find and the normal components of the force exerted by the plane, this one. So we know that this 80 cos 20 is being balanced by the normal reaction R. So R is equal to nothing but what? 8g cos 20. So R is equal to 8g cos 20. So 8 times 10 times cos 20 should be giving me the normal reaction, which is 75.2 newtons. That's going to be the answer. If the string is cut and the block remains at rest, but it is on the point of slipping down the plane, find the coefficient of the friction. So let me quickly add a page. Now the string is cut. And if the string is cut, what will happen is there is no tension at all. Okay, so the equation will remain the same. What was that equation? I copy this equation over here. Forward force minus backward force is equal to ma. I copy that one over here, but because the string is cut, there will be no tension at all. So my frictional force will become just 8g sine 20. So which becomes 8 times 10 times sine 20. But what is the thing? This frictional force is nothing but what we know. Frictional force is mu r. Mu r. R was just now we got it out as 8g cos 20. So you do not simplify it out. You can keep this one as 8g sine 20. The reason is it will be simply easy. 8g sine 20 upon 8g cos 20. So 8g gets cancels. Mu is equal to tan 20. Write in 3 significant figures. Mu is equal to 0.364. That's going to be the answer. So coming to question number 5. A cyclist and his machine have a total mass of 80 kgs. The cyclist starts from rest. So initial velocity is 0 and passes through a straight path AB. The free wheels moves without pedaling. When I say moves without pedaling means no work is being done. That is the most important thing. No work is being done. Okay. Down the path B. The path AB is in inclined at 2.6 degrees horizontal and is at a length of 250 meters. Given that the cyclist passes through B with a speed of 9 meters per second. So when we go from A to B, initial velocity was 0, final velocity is 9 meters per second. Find the gain in the kinetic energy and the loss in the potential energy of the cyclist and his machine, hence find the work done. So, gain in kinetic energy. Gain in kinetic energy, how do I find it out? Final kinetic energy minus initial kinetic energy. Final kinetic energy is half times mass is 80 times 9 square minus initial kinetic energy half times 80 times 0 square. So, they should be giving me 40 times 81, which is 3240 joules. That is gain in kinetic energy. Now what should I do? I should be finding it out, loss in the potential energy. So for loss in the potential energy, what am I going to do it out? Initial potential energy minus final potential energy, or final potential energy minus initial, doesn't matter. So basically what am I going to do is initial potential energy minus final potential energy, because loss, so I know that the initial value will be higher. So how do I find the initial potential energy? I draw a triangle over here. You can see that it's a triangle, height is h. So mgh, mass is 80, g is 10, height is nothing but what, again we go back and I use sine 2.6 is equal to h upon 250. From there I get the value of h as 250 times sine 2.6. So that is the height, 250 times sine 2.6 minus final potential energy, because it is reaching the ground, let it be 0. So when you do that one, keep the mode of the calculator in degrees. So 80 times 10 times 250 times sine 2.6 degrees. So in 3 significant figures, it becomes 9070 joules. That is the total potential energy. Now in the beginning I would have told you that he is not pedaling. That is the most important part. He is not pedaling, so no work is being done. No work is being done. So, and there is no friction over there, and hence the work done against the resistance of the motion of the cycle and his machine, that is being asked. Okay. So what am I going to do? I use total work done. TW means total work done is equal to delta KE, change in kinetic energy, plus change in potential energy, plus work done against friction, WDF. What do you mean by WDF? Work done against friction. TWD is total work done, and delta KE plus delta PE plus work done against the friction. And what is being asked in the question? Hence find the work done against the resistance to the motion of the cycle. So total work done is 0. Change in kinetic energy. So when I ask you change in kinetic energy, it is final kinetic energy minus initial kinetic energy. So which is 3240. Change in potential energy means final potential energy minus initial potential energy. Final potential energy is 0 minus initial potential energy is 9070 plus work done against friction. WDF means work done against friction. From here we get work done against friction, which is equal to 5830 joules. That is the way. If you don't use the proper symbol, then it will be automatically, you may be adding sometimes and subtracting sometimes. So see carefully. So total work done is equal to 5830 joules. So always in this one, total work done is delta KE. What is the meaning of delta KE? Always do final minus initial. Every time do only one concept, final minus initial. For potential energy also, always do final minus initial. Then you will be never be able to get an error in the symbols. So final potential energy was 0 and initial potential energy was 9070. And for kinetic energy, it was final minus initial. Final was 3240 minus initial was final was 3240 and initial was 0. So you will be never be getting any what it says errors in the symbols. That is answer for the first part. Now coming to the second part, the cyclist continues to freewheel, means he is not doing any work, along a horizontal path BD until he reaches a point C where the distance BC is d meters. The speed at C is 5 meters per second. The resistance to motion is constant and is same on BD as that of AB. Find the value of D. So the resistance of motion is going to be the same as that of AB. How much is that? It is going to be the same as BD. So we know that work done against the friction is 5830. Work done is nothing but what? Resistance in the motion, resistive force. I can write it as resistive force times distance is equal to 5830. So resistive force will be R and distance is 250 meters from A to B, right? This is the distance from A to B is equal to how much? 5830. So what is the resistance motion? 5830 resistive force divided by 250, which becomes 23.3. This is going to be my resistance force, resistive force. Now what is it being told? Now he comes to a C with a speed of 5 meters per second. So I quickly add one more page. Now I can consider the thing from C to D. So what am I going to do? Total work done. Total work done is 0 because he is still pedaling. He is not pedaling. He is not pedaling. So therefore, he is not pedaling. So therefore, the total work done is 0. Now delta KE. Delta KE means what am I going to do? Every time use final kinetic energy minus initial kinetic energy. Final kinetic energy is half times 80 times. The final velocity at C was 5, right? So 5 square minus initial kinetic energy half times 80 times. It was at B. So it is nothing but what? 9 square. So rather than it from C to D, what am I doing it at? It is from B to C. It is from B to C. So final kinetic energy is at C and initial kinetic energy is at B. So I do this one. So I get half times 80 common 25 minus 81. So it is 40 times 20 minus 25 minus 81. 25 minus 81 is nothing but what? 56. Negative 56. So it's going to be negative 2240 joules. That is delta kinetic energy. Now I'm going to find delta P. Because it is moving on a straight line, so there is no change. Final minus initial, it will be 0. Now work done against friction is equal to the resistance force, which is 23.3, and the distance is nothing but what? D, force times distance. Now I use the same concept. Total work done is equal to delta KE plus delta PE plus work done against friction. So total work done is 0. Delta KE is minus 2240 plus delta PE is 0 plus work done against friction is 23.3 D. So from there I get it out the answer as 2240 23.3 D is equal to 2240 So D is equal to 2240 divided by 23.3. So which gives me D is equal to, in three significant figures, 96.0. That is the distance from B to C. Coming to the next part, the cyclist starts to pedal now at C, generating a power of 425 watts. Find the acceleration of the cyclist immediately after passing C. So let me again add a page. I am doing in detail, that's the reason number of pages has been increased. So now at C, what is happening? His power is 425 watt. 425 watt. So we know that power is equal to force times velocity. So 425 is equal to force, I don't know. Velocity was 5 at C, if you remember. So the driving force is dF. dF means driving force will be 425 divided by 5, which is 8 times and 5 times 85. Driving force is 85 newtons. Now what is being asked? It is being asked that find the acceleration at C. So if you remember and you would have been following my videos, you can see that every time the same formula, forward force minus backward force is equal to ma. Forward force minus backward force is equal to ma. The forward force is my driving force 85, minus backward force is that resistance, which was 23.3, is equal to ma, 80 times a. From there, a is equal to 85 minus 23.3 divided by 80. So I take the calculator. So 85 minus 23.3 divided by 80. MA 80, then I'll be getting it out. The answer in three significant figures, 0.771 meter per second square. That is the answer. Now coming to the question number 6. I think so there are 6 questions, 7 questions. Okay. Question number 6. Particles A and B are attached to the ends of a light inextensible string which passes through a smooth pulley. The system is held at rest with a string taut and straight parts vertical. Both the particles are at a height of 0.36 meters above the floor. The system is released and A begins to fall. A begins to fall. This is the most important, and reaching the floor in 0.6 seconds. Find the acceleration of A as it falls down. So for A, initial velocity is 0. Acceleration is being asked us to find it out. The distance it falls is 0.36 meters, and the time it takes is nothing but what? 0.6 seconds. So I use S is equal to ut plus half at square. So 0.36 is equal to u is 0, time is 0.6 plus half a, I don't know, t square, 0.6 square. From there I get 0.36 is equal to half times a times 0.6 whole square is 0.36. From there a is equal to 2 meter per second square. The mass of A, next one. The mass of A is 0.45 kgs. Find the tension in the string while it is falling down. So again, every time the same formula that he has been using it out in M1, that is a very simple thing. What is that? Forward force minus backward force is equal to Ma. Forward force minus backward force is equal to Ma. Forward force is its weight 0.45 g minus the backward force is the tension is equal to 0.45 A. Just now we got the value of A as 2 and G value is 10, we know that, minus tension is equal to 0.45 times 2. From that gives me the tension value 4.5 minus 0.9, so which is 3.6 newtons. That is the value of the tension. Next, what is the mass of B? So I am going to use the same formula for B itself also, or the same concept. Forward force, it is coming down it's going up because of the tension, and its mass mg is equal to ma. So tension is 3.6 minus m, g is 10, is equal to m times acceleration is going to be a. So it becomes 3.6 is equal to 12m. So m is equal to 3.6 divided by 12, which is 0.3 kgs. So when I go back and draw the diagram, you will be able to understand this is a tension, and 0.4 g acts downwards, 45 g, and for this one mg acts downwards. So for a, because it is coming down, forward force minus backward force is equal to ma. For b, it is going up, t is the forward force, minus mg is equal to ma. This is the easiest way. Then the next, the maximum height above the floor reached by b. This is a 3 marks question, so you have to be very much careful over there. So what is the maximum height reached by b before it above the floor? So what I will do, I'll just erase this one now. See carefully over here, understanding the thing. A comes down 0.36 and it's over here. So simultaneously B also goes up 0.36 to that 0.36 meters, it goes up. At this position is B1. So we need to know what is the velocity of B1. So whatever is the velocity of A over here, final velocity, that is only going to be the, what is this, final velocity of B2, B1. Okay, so what am I going to do? Rather than scrolling up and down, I'll go it out over here and solve it out so that is easy. So for A, initial velocity was 0, acceleration is equal to 2, final velocity I don't know, and time is equal to, which has been given as 0.6 seconds. So I use V is equal to U plus AT. So that is equal to V is equal to 0 plus 2 times 0.6. So V is equal to 1.2 meters per second. So B will start with 1.2 meters per second. Because of inertia, B may not stop over here. It may go up to here and stop without reaching the pulley. So this type position is B2. We need to know how much is that distance it goes up over here. S. How much is that distance? We have to know it out. So for that particular part, for B, initial velocity was 1.2, final velocity is 0, and acceleration due to gravity, because it is going freely, because A is not pulling it anyway, so it will be minus 10 per meter per second square. Minus 10 per meters per second square. So V square is equal to U square plus 2AS. So V square is 0 square, U square is 1.2 whole square plus 2 times minus 10 times S. So S is equal to 1.44 divided by 20, which will become 0.072 meters. So now what is the maximum height reached above the ground? When you see the maximum height, it was this 0.36 plus 0.36 plus this S was 0.072. So when I add it out, 0.36 plus 0.36 plus 0.072, I should be adding it out. So total height will be, let me write it out over there. Total height is 0.36 plus 0.36 plus 0.072, which becomes 0.792 meters. That's going to be the maximum height. Coming to the last question, question number 7. A particle P travels in a straight line from A to D, passing through the points B and C. It travels in a straight line A to D. So let me draw a straight line A to D. In between the points B and C. For the section AB, the velocity of the particle is 0.5 t times minus 0.01 t square. Given that the acceleration at B is 0.1 meter per second, find the time taken for P to travel from A to B. So velocity from A to B is 0.5 t minus 0.01 t square. So when I find the differentiation of this one or derivative, velocity will become acceleration. 0.5t derivative is 0.5 and this becomes 0.02t. But the acceleration, it has been given it as 0.1. 0.1 is equal to 0.5 minus 0.02t. From there, 0.02t is equal to 0.4. So t is equal to 0.4 upon 0.02, which is equal to 20 seconds. So answer is 20 seconds. Next part. The acceleration from B to C is a constant and is equal to 0.1 meter per second square. Given that P reaches the C with a speed of 14 meters per second, find the time taken to travel from B to C. So at C, the velocity was 14 meters per second. Now here the time was 20 seconds. 20 seconds. What is the time over here is asking us to find it out. So let it be, this one was T1, T2. So from A to B, he has taken it as 20 seconds. So I is asking from B to C. So I need to know, first of all, the velocity at B. Velocity at B. So we know that the formula was 0.05 t minus 0.01 t squared. So it was 20 seconds, right? So 0.5 times 20 minus 0.01 times 20 squared. When I simplify this one, I will be getting it as 6. So now B to C. B, C. At B it was 6 meters per second. At C it was 14 meters per second. And acceleration is equal to same 0.1 meter per second square. What is going to be the time? So what is that? Initial velocity is 6 meters per second. Final velocity is 14 meters per second. Acceleration is equal to 0.1 meter per second square. Time is equal to question mark. So I use V is equal to U plus AT. So 14 is equal to 6 plus 0.1 t. So 0.1 t is equal to 8. So t is equal to 8 upon 0.1, which is 80 seconds. That's the part. And the last, what is the next one? Third part, the speed with which P reaches D. So V square is equal to U square plus 2as. I use the value V is equal to U square plus 2as. So I need to know V square value, which is U. Initial velocity from C to D is 14 plus 2 times acceleration times distance. Do we know the distance from C to D? So for that we have to have P travels with a constant deceleration of 0.3 and the distance CD is 300 meters. So deceleration, this time it is deceleration. So it is minus 0.3 and the distance is nothing but what? 300. So from C to D. The deceleration is given as 0.3 means acceleration is minus 0.3 and the distance has been given as 300. From there I get the value of V square is equal to 14 square is 196 minus 2 times 0.3 and times this one 600 times 0.3, which is V square is equal to 196 minus 180. So V square is equal to 16. V is equal to square root of 16. V is equal to 4 meter per second. And coming to the last part of the question, find the distance AD. He is asking us to find the distance AD. So we have to find the distance AB, then BC plus CD. CD is already given as 300. So S1, S2 and 300. If we add at all these things, we will be able to get that answer. Now, We know that velocity is equal to this much. That is the reason it is a 6 marks question. So it's a lengthier procedure. So we know that velocity is equal to 0.5 t minus 0.01 t square. So when I do the integration of this one, it becomes a distance. Integral 0.5 t minus 0.01 t square dt. So S is equal to 0.5 t square by 2 minus 0.01 t cube by 3 plus c. Now at t equal to 0, S is equal to 0. So 0 is equal to 0 minus 0 plus c. So c is equal to 0. So my equation for the distance will be equal to 0.25 t square minus 0.01 t cube upon 3. Now from A to B. A to B the distance is S1. So the time was 20 seconds, we know 0.25 times 20 square minus 0.01 upon 3 times 20 cube. When I simplify that, I should be getting in three significant figures 73.3 meters. Now coming to calculate from B to C. B to C, initial velocity we know, final velocity we know, and acceleration also we know, and the time also we know, 80 seconds. So when we know the initial velocity, final velocity, and the acceleration and time, we can do it at the distance S2 will be equal to half times u plus v times t, average velocity into time. So average velocity was 6 plus 14 times 80 seconds. So it should be giving me 10, 20 by 2, 800 meters. That is the easiest way, average velocity into time. If you want, you can do many other methods, but the easiest way is nothing but average velocity into time. If you still want to do, you can do S is equal to ut plus half at square. So now the total distance is S1 plus S2 plus 300. So S1 was 73.3 plus 800 plus 300. So when I write it out in three significant figures, 1170 meters. That's going to be the answer. So that concludes the paper. See you in the next paper. Bye.